BTEC Applied Science for AAQ, so it's Unit 3, Physics 2.6. What's that then? Well, it's about Newton's third law. We've done Newton's first law, we've done Newton's second law. This is Newton's third law. What's that then? Well, now Newton's third law, for every action, there is an equal and opposite reaction. Now, despite the fact that that's actually what Newton wrote down, I don't think it's very useful personally. I would rather say you've got two objects, object A and object B, and these two objects are exerting a force on each other. They might be attracting each other, they might be repelling each other, but two objects, A and B, if A exerts a force on B, then B exerts an equal and opposite force on A. Yes? So two different objects. If one of them exerts a force on the other one, either it pulls it or it pushes it, then the other one exerts an equal and opposite force on the first object. Yeah? Forces always come in pairs, acting on different objects. Okay? This isn't to do with, do you remember we talked about like equilibrium and you had like forces cancelling and stuff like that? It's nothing to do with that. Don't get it confused. This is when you've got two different objects. Yes? Two different objects. If one of them exerts a force on the other, then the other exerts a force on the first object. Let's look at these examples. Rowing. What the rower does is the rower, using the oars, the rower pushes the water. Yeah, let's get a nice blue pen going. Good idea. So the rower is pushing pushing the water in that direction, and so the water pushes the rower in that direction. Yeah, so the oar pushes the water that way forward, and if you like, the water pushes the rower in the opposite direction. So two equal and opposite forces. This bloke here punching a punch bag, yeah, he's applying a force to the punch bag. The punch bag is applying a force equal and opposite in the opposite direction. If you punched a wall, yes, then the wall experiences a force. The wall pushes your hand in the opposite direction and you break a few fingers. Yeah, so two different objects, equal and opposite forces. Forces always come in pairs. Somebody firing a rifle, yes, there's a force acting on the bullet, pushes it forward, and then there is a force acting on the person's shoulder, pushing them back, and this is why we get a recoil. Yeah, the earth pulls the moon towards it, yeah, because of gravity. The moon pulls the earth towards it, which is why we have tides, yeah, because the earth is, well, the water on the earth is being pulled by the gravity of the moon, and then as the earth rotates, this bulge in the water covers different parts of the earth. This is why we have tides. The cup on the table. So the cup is pushing down on the table is pushing up on the cup. Two equal and opposite forces. The two cars colliding, yes, they will exert an equal and opposite force on them for the same amount of time, so their change in momentum will be the same. Jets and rockets. Yes, there may be a question about this. Jets and rockets rely on Newton's third law. Basically, what you're doing is you're pushing out all of this exhaust coming out of the bottom of the rocket. So there's a big force acting on the exhaust as it's being pushed out. And so from Newton's third law, there's a big force acting on the rocket, equal and opposite, pushing the rocket up. Yes, so the push on the exhaust, pushing it out, is equal and opposite to the push on the rocket, pushing it up as it takes off. Look at this, two rugby players collide. Which one of those fellas would you rather be? Okay, when these two rugby players collide, they will exert equal and opposite forces on each other. Okay, one of them will end up in hospital. Which one do you think? So, quite a short video, this one, especially compared to the last one. When different objects exert a force on each other, the two forces are equal and opposite in direction. And that's Newton's third law. And be able to say what Newton's third law is, and be able to give examples of where you would apply Newton's third law. Remember, it's two different objects. Yeah, it's nothing to do with like equilibrium of forces or anything.